In question 7 we have trig equations, so part A for 4 marks wants us to solve for theta between 0 and pi over 2 for sine x is equal to sec x. Okay, so let's do that. So A for sine x is equal to sec x. Alrighty. So sec is 1 over cos. So for sine x is 1 over cos x. We definitely don't like having that cos x down there. So let's multiply through by cos. So then we get for sine x cos x is equal to 1. Now, we need one of our identities here to start. Sine of 2 theta is equal to 2 sine theta cos theta. Now, here we have 4 sine x cos x. So that's going to be 2 sine of 2x. So 2 sine of 2x is equal to 1 divided by 2 sine of 2x is equal to 1/2. Okay, so remember that we are solving for theta between 0 and pi over 2, so we are dealing with radians. So if we were now to inverse sine, we would get 2x is, so the inverse sine of 1/2 is 30 degrees, which is pi over 6. Okay, so before we worry about halving, let's think about sine. So, sine of x like this. So y is sine of x. Now it's 0 at pi and 2 pi. Now sine of 2x is a squash. So sine of 2x looks like that. So this would now be pi. This would now be pi over 2. So we can see in our interval x between 0 and pi over 2, we are going to get 2 solutions. So we know that 2x is pi over 6, so x is pi over 12, so that's one of our solutions. So that's this guy here. Now the other one, using the symmetry of the graph, is going to be pi over 2 minus pi over 12. So pi over 2 minus pi over 12 is let's see, so it'll be 6 pi over 12, so we're going to get 5 pi over 12. So our two solutions are x is pi by 12 and 5 pi by 12. Cool. Okay, then part B for 5 marks, and I would say quite a bit trickier. We want to solve for theta between 0 and 360, the equation 5 sine theta minus 5 cos theta is equal to 2. So, giving our answers to one decimal place. Okay, so given that we have a sine and a cos term on the left, we're probably going to need to use our compound angle formulas. So we could say that 5 sine of theta minus 5 cos of theta is equal to 2. Now we could say then that if we look at our angle formulas in the formula book, you can get this down below, remember. We're going to need a sine one, because if we used cos, we would get a cos squared term and a sine squared term. So we're going to need, given that we've got a minus in the middle, we're going to need to use sine of a minus b, because we've got our minus again. So we could say that this is some multiple r of sine theta minus alpha, and that is equal to 2. Now using the compound angle formula, then we would get r sine theta cos alpha minus r cos theta sine of alpha is equal to 2. So from this we can say then we know the coefficient of sine theta is 5. So that tells us r cos alpha is equal to 5, and very similarly r sine alpha is equal to 5. Now from that, if we divide r sine alpha by r cos alpha, we get tan alpha is equal to 1. Therefore, alpha is the inverse tan of 1, which is 45. Now, we can also square both sides of these, so we would get r squared cos squared alpha is equal to 25, and r squared sine squared alpha is equal to 25. From that, we can say that r squared times sine squared add cos squared is equal to 50. So all we've done there is add them together. Sine squared add cos squared is 1. So we get r squared is equal to 50. So r is root 50. So now that we know r and alpha, we know that root 50 sine of theta minus 45 is equal to 2. So, sine of theta minus 45 is equal to 2 over root 50. Now, if we inverse sine that, we get theta minus 45 is equal to 16.4. So if we add 45, we get our first solution, which is gonna be 61.4 degrees. Okay, so there will be another one. So sine of theta minus 45 is a translation 45 degrees to the right. So it looks something like this. So this x-intercept is at 45, and this x-intercept is at 2, 2, 5. Now, we know that our first solution here is 61.4. Now, to find the other one, we use the symmetry again. We know the distance between 45 and 61.4 is 16.4. So to get this other one, we do 225 minus 16.4, and that gives us 208.6. So our two solutions are theta is equal to 61.4 and 208.6. Good times.